All right, let's begin, everybody. So hope you had a wonderful weekend. Today we're working through 9A, sort of again a short, sharp, shiny exercise and then some polio work for your drafts, which are due this Friday. You're very welcome to put it in earlier if you want, and I can get started on them. Okay, so what we're doing here is we're going to have some probability experiment, and then we're going to add the results of the probability experiment together. So this is called a sampling distribution. So we'll read through it and then we'll get into the example. When we take multiple observations of a random variable and add them together, we get a new random variable. For instance, the weight of a carton of eggs is found by adding the weight of each egg in the carton. So each egg within the carton is randomly distributed, and so then if you add all the weights together, you get a new variable, the weight of a carton, and the weight of a carton is also distributed normally as well. Or the length of time for a Netflix binge, the same can apply. So if you're watching one episode or two episodes, the length of the binge can be found by adding the sum of each episode together. So we have two formulas here. We have Sn is the result of the first experiment plus the second experiment plus all the way up to the nth experiment. This is the distribution of Sn. And then we have the mean of Sn is n times the mean of x, and the standard deviation is the standard deviation times the square root of the number of trials. So I'm going to show you in this example what all that means. So we are 9A, sampling distributions, and here's our example. Here we have a discrete variable. All right, so that means there's two outcomes. You either get a 1 or a 2, and the probability of getting a 1 is 0.2, and the probability of getting a 2 is 0.8. Okay, part A, we're going to just do a recap of some of the skills that we've done in chapter 7. Find the mean and standard deviation of this distribution. Okay, so I'm going to go straight to my calculator there, not because I have to find the mean, but because I have to find the standard deviation, and we know that has quite a long formula. The mean is very easy to find. Okay, the mean is each result multiplied by its probability added together. Alright, so that's going to give us 0.2 plus 1.6. The mean is 1.8. But let's use our calculator to find the standard deviation. So I'm putting in row 1, we've got all of this data, and in row 2, these 2 points, column 2. So we have list 1, 1 and 2, and list 2, 0.2 and 0.8. Check my calculator settings. We've got list 1 against list 2. Mean 1.8, standard deviation is 0.4. Okay, so that's a skill we did in chapter 7. Any questions about that first part? Okay, so now let's take that and use it. Okay, so part B, state the meaning of S10. Okay, so this is our variable x, and so it's an experiment, probability experiment. You either get a 1 or a 2. S10 is the result you get when you perform the experiment 10 times and add all of the results together. So let's articulate that. S10 is the distribution that arises from 10 observations of x. Okay, so if x is a probability experiment, and we've got a new distribution that arises from 10 observations of it. The sum of 10 observations of it. Okay, part C, find the mean and standard deviation of S10. Okay, so we have the mean of S10 is equal to 10 times the mean of x. All right, so that formula is stated in the sentence above, Sn, mean n times mu, 10 times the mean. So this is going to be 10 times 1.8, 18. And the standard deviation of S10, all right, is the square root, so standard deviation of S10 is the square root of 10 times the standard deviation of x. Okay, the square root of n times the standard deviation of x. So that's root 10 times 0.4. And I'm just going to leave that as 0.4 root 10. You can have evaluate that to a few figures or simplify that. That's fine. Okay, so what have we done so far? Recap of chapter 7. Here we're doing a definition, the distribution that arises from 10 observations of x. And here, what is the mean of S10? All right, well, we expect it to be 18. What is the standard deviation of S10? This one here. Okay, so just to reflect it in terms of the context of like what we said above, we said the weight of a carton of eggs is found by adding the weight of each egg. Okay, the distribution of S10 is found, the mean of the distribution of S10 is 18. We saw that that's just 10 times the distribution of X, mean of X. Okay, all right, state the possible values of S2. Okay, possible values. Now this is probably the part where you need to pay attention, because this is where people have asked questions historically, because you're not just asking the formula here, not just applying the formula here. S2, what does S2 mean? S2 is the result that arises from 2 observations of this experiment. Okay, so if I perform this experiment, what's the lowest value I can get? 1, that's the lowest value I can get. So if I perform it the first time, I get a 1, I perform it the second time, I get a 1, and I add those results together, the lowest S2 can possibly be is 1 plus 1, which is 2. That's the lowest the distribution can be. The highest it can be is if I get a 2 the first time, and then I get a 2 the second time. So the highest it can be is 4, and of course we can get 3 by getting a 1 and then a 2, or a 2 then a 1. All right, so S2 is the distribution that arises from 2 observations, all right, adding together 2 results. And so then we can work out the probabilities of these events as well, based off of, you know, probability of getting a 1 and then a 1, that's 0.2 times 0.2. Probability of getting a 2 and then a 2, 0.8 times 0.8, and so forth. So that will pop up in the exercise. Okay, so yeah, for this exercise, it's just definitional, it's applying some formulas, and then bringing back some of the skills from chapter 7 to help us there. So let's try that out. Do a bit of time on that, do a bit of your folio. Yeah, up to you how you use your time.